Hello everyone, welcome to our new course on VR development in Unreal Engine. Today we will be learning how to develop the basics of a VR game inside Unreal Engine 5.3. The VR headset that we will be using is an Oculus Quest 3 and the version for Unreal that we will be using is Unreal Engine 5.3.2. So without any more delay, let's just get started. So our first view on this development side of Unreal Engine is how does VR development differ from normal Unreal Engine game development. So to start it off, I would say that VR development is a lot more complicated and a lot more device intensive when compared to other development sites such as normal game development. So why should we do VR development? What is different? Well, VR has its ups and downs. Let's start with the ups at first. So VR development has a lot more market than normal game development. Even though it is a bit more niche, it requires a lot more talent. That's why it's a lot more demanding. Along with that, using VR, we can create realistic simulations that feel like the player is inside the game or is inside the environment. So that's the plus side for VR development, and there are many more plus sides, but we will go through that as we go along with this beginner course. Now, the downsides are it's a bit more complicated. You need to have a good understanding of the basics of Unreal Engine development first before you start VR development. Secondly, it requires a lot more hardware to work properly. Usually it is a bit difficult to function VR inside a laptop, a 1650 or even a 2060 laptop. So I would suggest that you have a better PC that can handle such devices. And coming to the VR headset itself, VR development begins from Quest 2. So I would suggest for a beginner, you should get a Quest 2 to start your development. You don't need a Quest 3 or anything more expensive than that, since that would just be overkill. For a beginner, a Quest 2 is sufficient enough. And that's the three downsides that I would think VR development has. But those are not downsides, to be honest. Those are just some hurdles that can be crossed easily. So without any more delay, let's just see what VR development is. So I have the Epic Games site open right now. Here we are going to use the 5.3.2 version. You can just go here inside Unreal Engine and then to library, and then you can launch your engine from here or from up here. So I'm going to launch my engine. Also, this is the VR capture that the VR is capturing right now. We will get to that later. Once the project is open, we can create our own project. So I'm just going to name it here and call it VR project. Let me just restart Epic Games. So yeah, we have Epic Games open. I'm going to rename my project. I'm going to create a folder here called VR project. second. New folder. Okay, so I'm just going to go here. I'm going to select a new project here. So there are several templates that we can use. Firstly, we have the first person, the third person. We don't need all those. What we need here is the virtual reality template, the VR template that Unreal provides. We don't need the starter content, and basically this has all the basics that you need in a VR game to get going. I'm going to call it VR project and create. It's creating the project. It's going to compile the shaders, and while it does that, I'm going to explain a bit about how you can set up your VR inside your desktop. So basically the VR gets connected to your desktop either through Wi-Fi or through Airlink cable or any type of Type-C to Type-C cable or whatever you can use. So I would suggest using the Airlink cable if your Wi-Fi is not good enough, because that would cause lags and pixelated videos inside your VR, and you don't want that obviously. So if you don't have a good enough Wi-Fi, you can obviously use a direct cable connection for that. And now it's open. Now here we can see that we have a level right here. The level has a lot of things going on, so let's break it down bit by bit. So firstly, there's some lighting inside here. There's a directional audio that we are going to go through. There's a spectator cam. I'm going to explain that as well. And here are some things that are placed here that we can interact with when we are using our VR headset. So to play this, we need to set up our VR here, and to do that I'm going to show you how it is done. So I just get my VR here, get the controller. So since you can't see the view inside my VR, I'm going to show you here. So as you can see, this is what my VR headset is seeing right now. So if I open desktop here, I can basically get the desktop view. Obviously that would cause it to bug a bit, but basically the VR is seeing what is on the desktop screen right now. So here if I so this is the normal screen, the normal play. Now the VR headset preview is not set up here. We need to set that up first before we can get the VR playing inside Unreal. So there are two ways of doing so. You can have two types of apps for that. One is the Oculus Quest app, basically the Quest software that you can install with Oculus. You can use that, or you can use Steam VR to cast it to you can use Steam VR to interface it through Unreal. So I'm just going to go here, and inside project plugins I'm going to go here in edit, and inside plugins I'm going to search VR, and okay, it's enabled. So Basically you need to enable this OpenXR plugin here that will set up the VR implementations inside Unreal. Along with that, I think, yeah, we don't need that since it's now integrated inside OpenXR. So previously we needed to enable the Steam VR plugin as well. So and now that is implemented inside OpenXR, so we don't need that anymore. Now another app that you can install is the MetaQuest Developers Hub. Here you can monitor your MetaQuest 3. Also you can cast it to your PC, so it can record what you are seeing. Along with that, I need to set it up here as well. It's not detecting it right now. Let me just fix that. So one thing that we need to install right now is the Steam VR for implementing it. So I'm going to get Steam VR. I want to enable it. So let me just check if we have Steam on or not. We don't, so we need to install Steam as well. So first I'm going to install Steam right now. So once Steam is installed, we can download Steam VR, and basically what it does is that it can implement the VR to the Unreal itself. So whenever your whenever your VR headset is plugged in and you want to preview it inside Unreal, you need to enable this Steam VR. Either that, or you can also enable the Oculus Rift, but we are going to use the Steam VR right now. So that's downloaded. I will get back to you once I am logged into my account. Okay, so I got Steam VR installed right now, so it's running in the background, and once it's installed you can see that the VR preview is no longer grayed out. So now if I wear my VR headset, I started the standalone one. If not do that, you need to start the VR preview one first. Okay, so it's going to take some time to open up, or I can just close it. Let's just run for a bit, and it's going to close anyways. Meanwhile, I'll just do the VR preview here. So just wear the headset. The sound here crashed and I restarted. Also, you need to allow the unknown sources from your general tab inside MetaQuest. Once that is done, I'm just trying to reconnect it. So disconnect this and reconnect my headset. Okay, so the application is working, as you can see. So let me just wear my VR headset properly so that I can give you guys the proper demonstration of the VR template. So I have my VR headset on right now, and let me just find my other hand, and yeah, I have that. So as you can see, these are the VR hands. These are actually touch responsive, so if I just touch the controller, not move it, just touch it, then it's going to move the thumbs. Same goes with the index finger as well. If I just touch the trigger, the index finger just curls in away, and if I hold the trigger, it's going to curl the index finger. So I am for movement, I have my left joystick that's going to rotate me, it's snap turning me right now, and with the right joystick I can teleport to a given location. Now I can probably grab that if I just move a bit closer. Now, as you can see, I have the gun right now in my hand, and I can basically use it to shoot balls or any other projectiles. And there's also this cube. Obviously it's a bit difficult to do this in a closed area, so I would suggest everyone to have an open space to do this properly, or else you might just crash into stuff around you. So if I just do this, I can, as you can see, I have grabbed the cube right now. The cube also has physics and stuff, so if I throw it, it's going to fall down. So this is the basic VR template that it gives. Also there's things inside here, so there's some lighting, and there's also some spatial sound that you can feel once you wear a VR headset. So basically this is the sound source, and it's providing a spatial sound so that it feels like when I'm not facing towards it, the sound is coming from my back. And that is a no teleport zone, so basically it's not going to let me teleport inside that space. And basically that's the basics of this template. So let me just turn this off now. I'm going to open the headset right now. So this is the basic VR template that we are provided, and you can go through this VR template. You can see how everything works, how these graph components work, or how that sound source works. You can do it all on your own. So that's that. There's also a spectator cam that switches your view so that you can take any shots that you might like. Let me just open the blueprint here. So we can see that we can change our view from spectator to normal. Let me just see the input action for this. Go to content, VR template, input, and I think it's IMC menu. So what's it called? It's called IO spectator toggle. Okay, so it's not menu. Then it should be, let's check IMC hand. No, IMC default. I'm just going to search it. So I'm going to press Ctrl P and search VR spectator toggle. Yeah, this one. And I'm going to browse where this is. Okay, so it's inside this one. So let me just check which one it is. So it's on tab for keyboard. So if I press keyboard, it's going to switch it to that camera. And we can take any type of third-person cinematic shots for the frame. So that's that. Along with that, we also have a VR menu that I can show you. Let me just put this back on. Go to desktop. I'm going to play. Okay, so I hope you guys can see this. Just check. Yeah, it's visible. So if I press, one second, if I press this button, yeah, so this is a menu that we have. So we can reset our orientation, we can restart, or we can do real life. So these are some UI elements that you can add to your VR. And let me just press tab right now. And it's switched to the VR camera right now. So the VR camera is tracking me. Obviously I can't see that perspective. It can only be seen on the PC itself. So I guess you guys can see me moving around. You can't see my body because there is no body right now, but you can obviously see the hands right here. So hey, anyways, so that is the basics of this VR template. Press escape. So that gives the basic rundown for the VR template we have. Now I'm going to show you some settings that we can use to export our VR games, since VR games usually need a lot more optimization for the headset itself, since the headset is not as powerful as the PC. But there are two types of environments that two types of games that we can have in VR. One is a VR native game, so it is only native for the headset itself. It doesn't run on a secondary PC or a secondary machine. And the other is the one that runs on a secondary machine. So basically those run on the machine and get casted to the headset when it is connected. So those can be a bit more device intensive when compared to the native games. But the native games don't require any external PC or any external machine to run. It only requires the headset itself. So some examples of VR native games are Creed VR, sorry, not Creed VR, that's a PC game and that runs on VR. Some native games are Super Hot VR. Then we have Half-Life Alyx, and some PC VR games is, as I said, Creed VR, then there's Beat Saber, and so on. Resident Evil 4 is also a VR native game that we can play. So anyways, those are some examples. Both have pros and cons as well. You can research more into these types of games and what they are, but the basic rundown is the VR native games, they usually work just on the headset, and VR PC games work on the PC and get casted to the headset. So to export for VR, we need to set up a few settings. Also, one small note, if you need to package a game for the Quest itself, so a native game for Quest or Quest 2 or Quest 3, then you need to have settings set up as Android APK, since the VR installs APK into itself to play the game. So with that done, let's get into the settings after this. Okay, so we have the settings out here. So there are a few settings that we need to set for VR development. Firstly, I'm going to search DirectX 12 or just DirectX, yeah. So this default RHI will be DirectX 12. Next that we need to do is SM6. So we need to enable, yeah, here T3D12 SM6, we need to enable that. Next we need to search up static lighting. So allow static lighting, we need to turn that off. It requires a restart, but there are a lot more changes that we need to do, so we are going to do all those changes and then restart altogether, or else it will compile shaders as we go. So moving on, we have so I'm going to turn off forward render. Under forward rendering, under forward renderer we have forward shading. We need to turn that off. Next we are going to have global illumination. So this should be set to lumen, dynamic global illumination. Next that we need to do is I just want to search it out here. I can just search reflections. Yeah, so reflection method will be lumen. Reflection capture resolution, I'm going to reduce it to 64. You can have it around 96. Actually, I'm going to keep it 96. 128 is a bit too much for lumen and it can cause the game to lag, so I would suggest keeping it around 96. Or if you are recording or doing anything else, you can keep it around 64, but I'm going to keep it around 96 since this is a good enough PC to handle that. So it's going to build reflections. Next setting that is so I'm going to turn support hardware ray tracing on. I'm going to set it to yes. Next I'm going to search position. I'm going to turn that on as well. Next I'm going to search anti-aliasing. My anti-aliasing method will be MS double A multi-sampling. There's some other settings as well for anti-aliasing. I'm going to search. Also, I'm going to turn mobile HDR on under VR. This is required for packaging for VR as well. So I'm going to keep it on from here. Exposure. Next I have MSAA. Yeah, so under default settings we have anti-aliasing method. I'm going to keep it TSR here, temporal super resolution, and this one will be MSAA for mobile anti-aliasing. Okay, so the MSAA sample count will be 4x MSAA. And one last thing, to search is effective. Yeah, so support sky atmosphere affecting high fog. I'm going to enable it as well. So I think all my settings are done. I'm going to restart now. Save everything up, and it's restarting. It's going to compile all those shaders as well. So this is going to take some time, and I'll be back once this is done. Now we are going to create a grabbable remote that we can use to change actors and the static meshes of the actors. First, we are going to create a basic grabbable actor like this cube that we already have. Now basically what a grabbable actor is it can attach to our hand when we press a certain input, and when we throw it, it can simulate physics or drop to the ground. So that is the basics of a grabbable actor, and basically we can use this grabbable actor to create different types of devices or components in a scene. So to do that, we are going to use a previously made grabbable actor. We already have a few of those lying around. So one is this gun, and the second one is this cube out here. So I'm going to select this cube, and inside blueprints we can see that the blueprint is actually empty. So what creates this grabbable actor? So it is this grab component that we have. Basically what it does is that it turns any actor into a grabbable actor, this grab component, and we can basically have functionality in that actor and just add a grab component to that, and we can basically use it as a grabbable actor. So I'm just going to duplicate this grabbable actor that we already have. So I'm going to press this browse option. Yeah, so there's the cube. I'm just going to duplicate that and create a pp underscore grabbable port. I have a typo out here. I'm going to fix that. So yeah, grabbable remote. I'm going to open that, and obviously we need a mesh for our remote. So I'm going to get that using using Sketchfab. So I'm going to search up Sketchfab, or we can just check if there's something that we can use through Pixel. So I'm going to go here. Where was it? Pixel Bridge. To let that open up. So basically, if you know what Pixel Bridge is, then that's great. But basically, what it is that it's a free marketplace from Unreal where you can implement it inside Unreal Engine, where you can download assets and materials and textures for your project. And those are very high quality 4K assets that you can get. We won't be requiring that much high fidelity. We are going to get some low quality assets that we can use. So let me just search if there's something called remote or not. Okay, so there's nothing on here, but basically we can also get some other things like basically what the remote is going to do is it's going to change the actors mesh, so we can download those meshes from here. I'm going to get that to soon, but first let's just get the remote itself. So I'm going to go to Sketchfab here, and I'm just going to search up remote. So Sketchfab is a great site from where you can download meshes and environments. It has a lot of downloadable content, so you just need to search up what you want, tick downloadable here, and get anything that you want to. So I think I will use this. This one looks simple enough. So I'm going to go down and I'm going to click on download 3D model. Let me just sign in to it real quick, and I will get back to you once I have downloaded the asset. So I've downloaded the remote from Sketchfab. I downloaded it in GLB format and just imported it in Unreal, so you can do that pretty easily. So I'm going to go here, set template and blueprints. So I've created a separate folder for my remote, and this is the remote. As you can see, it's pretty big, so we need to scale it down a lot. So I'm going to do that here. Here inside viewport, I'm going to select the static mesh for the remote. I don't need this, and inside static mesh, I'm just going to drag this one here and place it here. Now obviously this is quite big, I don't need it to be this big, so I'm just going to scale it down to I think it's still big. Okay, to compare it with our controller, I can just add another static mesh. And I'm just going to set it to our controller. So the controller blueprint will be let me just search it up. I'm just trying to search it up, so I'll search and yeah, I think we can use this as a reference. So yeah, it's still pretty big. So I'm going to scale the remote a lot more. So you can take with the size of it so that you can find how large you want the remote to be. I think this is a good enough size for me, so I'm try a bit smaller, so around 0.0035, and yeah, so that's a good enough size. I want to again set this one as root and delete this one. Let's just place it in the level and let's see how large it is. Okay, it seems good enough. Now that is done, we need to work on the grab component. So what the grab component is that it basically determines what type of grab you want. So in a p grab, it's going to just be relative. So let's say I'm holding it, let's say this is the object that I want to grab, and if I just grab it, it's going to maintain the relative distance between those. But in snap, it's going to basically snap to our hand. Here I'm going to use snap mode, and let's just see if it works or not. I'm going to turn on my VR right now. You can also use the free mode if you want to. It totally depends on the situation as well. In this case, I'm going to use the grab mode, snap mode, because I want the remote to snap to my hand instead of just floating in the air while maintaining the relative distance. Okay, so VR preview is not enabled. I think Steam VR is not running. I'm trying to search Steam VR. It's launching. Let it launch, and I'm just going to restart the engine once again. So I'm just going to close that. Also, I'm going to close the Sketchfab, and now I'm going to restart engine from Epic Games. Once that is done, yes, you can see the VR preview is available now, and we can test the remote right now. Okay, I'm going to wear the headset properly. Teleport there. I hope you guys can see the preview. Yeah, you can. Yeah. So let me just I can't grab it properly. Just check it with the cubes there. Okay, I can grab the cube. I think it's because of placement of the remote I can't grab it. think it, okay, like somehow grabbed it. Yeah, so it's not properly aligned to my hand right now. We need to align it to our hand so that it faces outwards. Let me just align that once. So close the VR preview. And next I'm going to open the blueprint for the gravel actor. I think it's because it doesn't have a proper collision that it's not working properly. I'm going to open the mesh and I'm just going to check the collision for this once. Yeah, the collision is a bit weird and a lot complex. We don't need this much complex of collision. Just going to remove this and add a box collision. Next thing, I need to align the remote to our hand itself. So to do that, I can just get our hand controller that we have. So if I just search, go inside VR template, inside blueprints and VR pawn. So basically what VR pawn is, it is the player pawn that we have for the VR itself. So here on our hands we do have a visualization tool. We will just copy this. I'm going to copy the right one. So yeah, this static mesh, and I'll place it here. Also I'm going to bring it out. It should have the controller view, but I think it's not imported properly. That's why it's not showing the controller. As you can see, there's no static mesh here. To add a static mesh for our one. So yeah, let me see what we can add. Oh yeah, we have a few controllers out here, the HTC Vive controllers. We can use those, or we can obviously use these Oculus controllers as well. So I'm just going to search right_Oculus. So yeah. So basically this is the controller that this is the Oculus Quest 2 controller. But this will work because this is just for visualization purposes on how to align the static mesh. So I'm just going to align this. So it will be approximately like this, I guess. And I'm going to set this as hidden in game. And also I'm going to turn off collision for this. So no collision. Play it again and let's see if it works or not. that's the other. Okay, so go there. Let's see if I can grab it somehow. Yeah, okay, so it's still not getting grabbed properly. I think it is because of the snap option that we have, since it snaps the rotation of the remote towards 000 when we are grabbing it. So that could be the issue that it's causing, but I think we can fix that. Obviously, I'm going to leave it here. And I'm going to close this. So inside this remote, we have to basically set the grab for that. So see again. I think this will work, but let's just give it a try. So this won't be working like that, but yeah, also you can notice that the remote also has physics enabled, so when I leave it or just drop it, it's going to go down as gravity is working on it, since the physics for the remote is enabled right now. So if I just open the blueprint for this, let's see what we can do here. So for the grab component, I need to align the component as well to the static mesh so that it is visible. I'm going to set it here. Yeah, so as you can see, the grab component is not aligned properly. So I think this should work. I hope that it is set to hidden again. Yeah, so it's set to hidden, and now I'm just going to check if this works or not with our remote. Just take from here, and you guys can see. Let's get the other hand, and let's see now. Okay, so where did the remote go? The remote somehow vanished. Let me see what happened. So I go here. So the remote is here. I think it locked out or something. Also I need to set its collision. I think the collision setting got reset again. So I'm going to search collision, and yeah, I'm going to set it to no collision. Compile and save. Let's test it out now. So we have our remote here. I'm going to try to grab it again. Okay, it's a bit difficult to grab it here from here, but yeah. Okay, so it's still not working properly. Okay, so let me see what is the issue here. I will get back to you once I have solved it. So I found the issue, and it was quite a silly issue. I basically changed the rotation for the static mesh that we added for visualization, and not the grab component. So anyways, that's fixed now. So I have the rotation set here for the grab component, not the static mesh of course. And now I'm going to play it, and you guys can see that the remote is getting aligned properly. So if I move forward and again if I move close to the remote as much as I can and try to grab it, yeah. So as you can see, it's now grabbed properly into my hand. Obviously there's some fine tuning that can be done. That obviously depends on the mesh and the hand itself, but yeah, this is the basic of the grab component, and if I drop it, it's going to drop down. Once again, if I pick it up, it's going to attach to our hand. So yeah, and if I want, I can just take it and throw it away. So yeah, it works like that as well. So let's start with the next part, and that's making this remote function. So we are going to add the functionality and basically make this remote change meshes around us. So let's say this is going to be an actor, and whenever the remote is pressed, then we can change the static mesh of this actor. So that's what we are going to do next. So next thing that we are going to do is add some functionality to our remote. So I want to go here. So what our remote is going to do is basically it's going to spawn a trace, and if the trace hits a transformable actor, then it's going to basically change the mesh for the actor. So I'm just going to go here, and I'm going to basically create a new actor first. So new folder and call it transforming actor. And I'm going to make an actor blueprint, so bp underscore transforming actor. And I'm going to import a static mesh as well. So what it's going to do is that it's going to change its static mesh based on the clicks of the input. So I'm going to first import some static meshes. So I'm going to create a new folder called meshes, and inside this I'm going to add some meshes from Pixel Bridge. So here, and let's just search some plants or whatever we can find around. Okay, I need to sign into my Epic Games and then I can download those. So I will get back to you once I have downloaded a few meshes. So I've logged into my Epic Games account and now I'm going to download it. Downloading from Pixel is quite easy. You can just select the mesh you want to download, uh, click this drop down and select the quality. I'm going to set it as low quality. I don't need too high for quality for something as small as an apple. And I'm going to download that. I'm going to download this apple as well, and this one as well. And there's some other meshes that I want to download too. Let's see what else we can find here. So, let's try some interior meshes. Yeah, so we can download this chairs. So download this. Okay, so we have downloaded quite a few assets right now, and we can use those. Also, we won't be requiring this meshes folder since Pixel creates its own folders called Megascans. So I'll go here. I forgot to add all those meshes, so I'm gonna go here and zip bridge. To search it again. I'll just add these chairs for now. We can add the apple later. So 3. So we have 5 meshes of chairs imported. Now what we are going to do is going to create the actor. So yeah, here inside transforming actor, I'm going to set it. So what we'll have is that we are going to cycle through an array of actors that we have. So I'm going to set actors and call it, and it will be static meshes. And it will be an array. To compile and add 5 elements. So content, Megascans, 3D assets. I'm going to add those chairs one by one. 1, 2, 3, 4, and 5. Oh wait, I think 4 and 5 are the same. Right. Let me just check. So this is 4 and this is 5. I think, yeah, I think they're slightly different. Yeah, they're slightly different. Not a huge difference, but yeah. So yeah, we have our chairs imported here, and now I'm going to create an interface that will interact with between the remote and this actor. So I'm going to create one. So content, between folder called blueprints, and create an actor. Sorry, not an actor, my bad. delete it, and it will be blueprints interface. Yeah, blueprint interface. I will call it bpi underscore remote. Yeah, we have a function called change mesh. So I'm going to basically implement this here. File, and we should have, okay, that's it. It is here, and we should have the function right now. Just have to file and save this once, and yeah, so we have this event here, and what this does is that it's going to cycle through this actors array. Also, I need a current index for this, and it will be of type integer. If current index is greater than equal to so if our current index is greater than or equal to the length of this array, then we are going to minus it by 1, and if it is not, then we are going to plus the current index by 1. So I'm going to on a branch here. If it is true, then I'm just going to get current index, decrement it by 1, and then I'll be get actor from this. And I'm going to set the static mesh for this. So set static mesh. And if it is false, I'm going to just Control D this whole thing. I will also duplicate it. And once this is done, I'm just going to increment it. Okay, so I will also require another branch here, or I can do one thing. Instead of incrementing and decrementing it, I can just create another integer that will basically decide whether it will increment or decrement. So I'll call it decrement. So its default value will be 1, and if we have reached the length, then I'm going to set it as -1. If it is it is not at the end, then I'm going to check if it is 0 or not. If it is 0, then I'm going to set it as +1. So I'll add another branch and check whether this is not equal to 0, but less than 0. And now I'm just going to set the static mesh as the current index that we have. Also, I'm going to change it a bit here, so I'm going to subtract it by 1, and I'm going to just check if this is greater than or equal to that or not. So if it is at the last index of our array, then it will set it as -1. We are going to get the mesh, and after that we will just add the increment or decrement to our current index. So I get this, and I'll just add it. So yeah, that will do. And if we are less than, sorry, it won't be less than, it will be less than equal to. So if we are at the last, sorry, our first index, so that is 0, then it will set the increment to 1. It will change the mesh, and then it will keep adding the increment. So that's it. Also, we need to do this in the construction script so that it sets our static mesh, to set it to the default of 0. And I'll just place this up here. Now for our remote, what it's going to do is that basically if we open our gun here and check the blueprint, then we can find that we have an input action called shoot. We can use that to trigger the change for the mesh, and also I can so what this does is that it's shifting the input from the player to the remote itself, so we can use this as well. So I just want to copy this entire thing here inside our gravel remote. So on grab, it will shift the input to our grab component. Just check what this grab component snap is. So basically it's the grab component itself. So we have that. Yeah, I think this will do. And next thing that we need is this input action. So I'm going to copy this as well inside our remote. So replace these snaps with our grab component. Also, we need to change those events as well. So I'm going to add this event here. Another one here. So yeah, these two are our new events that will be called. And also here we are just going to spawn a line trace from our remote. So spawn line trace by channel or objects. We can use objects as well, or we can just use the channel itself. So I'm going to use the channel. So line trace for channel. Line trace by channel. And so our start location will be our remote's location. So get location. And our end location will be I'm going to get the forward vector for our actor. Get forward. Yeah, this one. And I'm just going to multiply it. Convert it to a float, and I'm going to multiply it by 1000. And I want to add it. So I'm going to draw the debug for debug purposes, and from the out-hit actor I'm going to break the hit result. Also, if return value is true, then I'm going to check if hit actor implements interface, and the interface will be our PPI remote. It does implement our interface. I'm going to call our interface function, which is some person name here, change mesh. Yeah. So I'm going to call change mesh right here. Now let's see if all of this works or not. I want to get the chair here, and I want to hit play. Okay, so I have my controller. So right now obviously it won't do anything since we don't have the remote, but if I move forward and just try to grab the remote, if I can, that is, yeah. So as you can see, it basically draws line trace, but it's not towards the forward actor, the forward vector. It's somewhere from here. Also, I think the meshes don't have their collision enabled. That's why the line traces are going through. So I'm going to change those as well. So let me just stop the preview again, and let's see. So here are the meshes. I'm going to go here inside our meshes folder, and I'm just going to add a box collision. So add box collision, and I'm going to do this for all our meshes. Add box collision. So yeah, we added our collisions. I'm going to close all these. Obviously I won't need this as well. Also, next thing that I need to fix is the forward vector. So if I add an arrow for it, as we can see, the forward vector is towards the right actually. So what I need is actually the inverse of the right vector. So let me just delete the arrow, and I'm just going to change this and get the right vector. So let's see if this works or not. Find my other hand. Okay, I got it. Yeah, so if I move forward, yeah, so it's perfect now. If I just hit it, okay, I did hit the actor, but it is not changing the mesh. Let me see why that is. I'm going to press escape and to basically put a breakpoint where the line trace hits. So inside our remote, so this is where our line trace hits. I want to place a breakpoint here. I don't think this is getting executed, because if it did get executed then it would have worked. I want to press a breakpoint here, and I'm going to test it. Okay, let's get the right hand first. Okay, let me just rotate myself real quick, and yeah, so we did hit the breakpoint, and the condition is going to be true. Okay, so this is getting executed. So then, yet it is not changing. So there could be an issue with this. Okay, I see what has happened here. So I haven't connected this pin, so yeah, that was the issue that was going. So I think now it should work. Okay, so let me just get the remote. And now if I forgot to remove the breakpoint again. Nine. Okay, just pause that. Yeah. Okay, so I'll test it again. Okay. Yeah, take out my hands. Let me just grab the remote and yeah, it's changing the mesh. Perfect. So that is how you can basically use a blueprint or a grabbable blueprint which can basically change actors around you. You can place a ton of these actors around you and basically use this blueprint or this remote to change their meshes. And once you're done, you can just say throw it away. I actually like doing that for some reason, but yeah. So that is our remote done. Next thing that we are going to look into is the UI element of VR development. So as we have seen before that we had a we had an UI on our hand for the VR handset. So we can basically make a few changes to that and create our own UI element. So let me just open this menu here. So this is the basic menu that is given to us. This basically attaches to our hand where we can basically see this. So we can create a new button for our widget, and I'll just copy this. Let's see. And I'm going to call it spawn button. And this will be spawn button as well. So yeah. And I'm also going to change the text inside this. I'm going to call it spawn. So what it will do is that it's going to basically spawn something when it is clicked. So I'm going to go here, and on clicked I'm going to basically I will be spawning the actor that we just made. So I will just call it spawn chair. And on clicked it will basically search if there are any chairs or not. So if there are any chairs, then it won't do anything, but if there aren't any chairs, then we can basically spawn our chair. So spawn actor from class. I'm going to search transforming actor, and the transform will be I'm going to create a spawn location for this. So I will have another actor called spawn location. I will remove this and blueprint class actor pp spawn location. I can just drop it somewhere. Let's say here. And in the widget menu, I will get the actor. So get actor of class pp spawn location, and I will just get transform. Get actor transform, and I will just plug it in here. Also, for our transforming actor, one thing that we can do is create this, set it as gravel as well. So, or we can just add physics to it or anything. But I think I will make it gravel. So, gravel component. I will set it as free. I don't want it to snap to my hand. And another thing that I will do is set its physics as true. So simulate physics as true. So simulate. Where was it? Yeah. Wait, not this. Okay, so for some reason the simulate physics is off. I don't know why, but alright, I guess. Anyways, so we can basically spawn it here through our widget. So, and if it is valid, then what we can do is we can delete the chair itself. So I'm going to get it. So also, instead of doing this, I can just get actor of class. So this will basically remove the actor. So yeah, that seems good enough. I'm going to compile, hit save, and actually I'm going to rename this as spawn / destroy. Compile and save, and let's test it out. So I will wear my headset now. Okay, so we had our UI. One second, let me just find my UI. Yeah, so if I press spawn / destroy, we can see the chair gets spawned, and obviously I can use our remote as well for that. So I just need to, yeah. So we can change that as well. And I drop my remote. So yeah, the chair works perfectly, and basically with this we can conclude our VR course as well. Also, before doing that, I would like to show the destroy function as well. So yeah, so that removes the chair. If I press it again, it's going to spawn again. Spawn, remove, whatever. So yeah, the UI works as well. So with that, we basically conclude our course. So basically this is just a taste of what VR can do. It's pretty basic, pretty beginner level, beginner friendly, but if you guys are actually interested to learn more about this, you can contact us up and we can create a full-fledged course regarding this, so that you guys can learn a lot more than just making chairs and remotes. We can create a whole game course where we can create our own VR game. But yeah, this is pretty much the basics of what VR development is in Unreal. It's a bit more complicated, as I said, from when compared to normal game development, but with proper learning and proper practice, you can obviously master VR as well. So anyways, I hope this was easy for you guys to understand and you guys enjoyed the course well enough. And with that, I would like to conclude this course. Thanks for watching.